Well, Algebra Geometry 3 classes, good morning, good afternoon, or good evening. We are going to finish up Unit 6 notes here today, and that's going to deal with graphing absolute values. One of the things that we'll talk a little bit about that, certainly terminology you've heard before is we're going to consider f of x equals absolute value of x, our parent function. Now, the way you come up with these points, when you take the absolute value of -2, absolute value turns it to positive. For the -1, again, absolute value turns that to positive 1. 0, 1, and 2 don't change. So -2, 2 would be there, -1, 1, 0, 0, 1, 1, and 2, 2. The graph of the parent function ends up being a V shape. Domain is negative to positive infinity. The range is 0 to infinity. We put a bracket around it because you actually include 0. And then the other two terms that are going to come up is we're going to call this point down at the bottom of the graph the vertex. And, as I even just said, because that point is at the bottom of the graph, we're going to say that vertex is a minimum. Now, we're going to, refer to a lot of the transformation type topics we've looked at throughout the course of this semester. The first thing that we're going to look at is what happens if you either add or subtract a k value at the end of your graph. So, if you add a value at the end, that's going to shift your parent function up. If you subtract, it's going to shift it down. Now, from there, what I am going to do is just do a quick rough sketch. And then for the first one here, I'm going to just basically move every point up 2. And then we'll talk about all of the different characteristics. So to start, when you shift it up, the vertex is now 0, 2. It's still at the bottom, so it's a minimum. Domain will not ever change. What does change is our range is now positive 2 to infinity. For equation 3, again, I am going to sketch our parent graph here. Now, what's going to happen? Our vertex is going to move down 1, 2, 3, 4, 5. And again, I can take each of these points as well and shift them all down 5 as well. Now, in terms of what we end up with, our vertex, when you shift it down, is 0, -5. Again, it's still at the bottom, so it is a minimum. Now, domain, once again, never changes, negative to positive infinity. Your range is -5 because it shifted down to positive infinity. So that's what happens when you shift things either up or down. Now, the next thing we're going to talk about is if you have what's viewed as an h value inside. Now, when you have something inside, it actually works opposite of possibly what you would expect. So when we have x minus 2, if you set it equal to 0, x would equal 2. So this actually shifts it right 2. If you have x plus 4 equals 0, x would equal -4. So this actually shifts it left 4. So again, I am going to just real quickly sketch our parent function. And then I'm going to take our vertex and shift it right 2. Now, when I sketch this one, our vertex is now at 2, 0. Again, it is still at the bottom, so it's a minimum. Again, domain does not change. For this one, neither will the range, because your y value, which is the range, still starts at 0. Now, For example 3, again, I am going to sketch our parent function and shift it left 4. So again, I'm going to take my vertex left 1, 2, 3, 4. And when we do that, your vertex now is negative 4, 0. It is still a minimum. It's at the bottom of the graph. Domain, as I've said, will not ever change, negative to positive infinity. Because our y's still start at 0, the range is 0 to positive infinity. And again, because you actually go through that minimum point, we do use a bracket there. All right, if you have printed these off and are following along, I am moving on to the second page now. Now we're going to talk about what occurs if you have an a value in front of your absolute value. Well, again, I will go ahead and sketch the parent. When you have an a value in front, that works a lot like slope. Now, if it's not already written as a fraction, I like to go ahead and even write that in as 2 over 1. Well, our vertex is still going to be at 0, 0. The only thing that changes is now I'm going to go up 2 over 1, up 2 over 1, and I'm going to go up 2 left 1, up 2 left 1 as well. So, when a is greater than 1, if you remember, that's where we talk about the graph gets narrower. For example 3, I'll go ahead and sketch my parent once again. Now, a is 1/2. So, again, from my vertex of 0, 0, I'm going to go up 1 over 2, up 1 over 2. Here I'm also going to go up 1, left 2, up 1, left 2. The biggest change for this one is when a is not only less than 1, but it does also have to be greater than 0. Your graph will be wider. Again, vertex is still 0, 0 on both of these. Graph, it still has a minimum at the vertex. And then for both of these, I'm not going to write them out twice. When you simply either make a graph narrower or wider, your domain and range remain the same. So domain and range for both negative to positive infinity, range is 0 to infinity. The last thing that we are going to talk about is what happens if a is less than 0. That's the one time where things will change, and actually quite a bit from what was up here. So, again, for the first one, I am going to, again, sketch a parent function. Now, I am going to rewrite this first one as y equals -1 absolute value of x. So again, this way, I can even set up my fraction. Now, my vertex is still going to start at 0, 0. The main thing that's going to change is because now a is negative, instead of going up 1 over 1, I'm going to go down 1, right 1, down 1, right 1. I'm also going to go down 1, left 1. And so what ends up happening when a is less than 0, the graph flips over the x-axis. When the graph flips, the vertex is now a maximum. Now, when that occurs, your domain is negative infinity to positive infinity. So again, that doesn't change at all. Your range is going to be the significant difference because now the graph is actually pointing to negative infinity. It stops at the maximum of 0, so the range is negative infinity to 0. For the final example that we're going to graph, again, I am going to sketch my parent. Now, main thing is here again, my a value is negative 3 over 1. So I am going to start at 0. I'm going to go down 3, right 1, down 3, right 1, and down 3, left 1. Down 3, left 1. And the vertex again is 0, 0. Because the vertex of the red graph is again at the top, it is a maximum. Domain and range, because it's flipped, again, kind of like what I did up here. These two graphs have the same domain and range, so do these. I'm not going to write that out twice for you guys. So, other than that, just a few things that we're going to kind of talk about some examples of without actually graphing, looking at what would happen. Well, if you notice, the first two of these have a k value. It's either going to shift it up or down. This one, since it's plus 6, moves up 6. Minus 4 moves down 4. The next two, 4 and 5, now have h values. Again, those either move the graph right or left. Those are the ones that kind of go opposite of what logically seems to fit. If it's minus, it moves right. If it's plus, it shifts left. So, minus 3 is going to shift the graph right 3. Plus 2 is going to shift the graph left 2. And then the other thing that I am going to do now, your vertex, if it shifts left 2, is 2, 0. Or negative 2, 0, excuse me. Here, if it shifts right 3, 3, 0. Down 4, 0. Negative 4 is your vertex. And then up 6 has a vertex of 0, 6. 2/3. When you have an a value, because it is now less than 1, the graph is going to be wider. If all you do is make a graph wider, vertex doesn't change. Now, y equals negative 6x. This is one that's good to talk about. It's kind of like what happened on this example. The negative is going to flip over the x-axis. The other thing, 6 is greater than 1. So the graph is also going to be narrower. Your vertex will still be 0, 0. Now, question 8 has both an h and a k value. Well, the minus 1 is going to move it right 1. The plus 2 is going to move it up 2. That is going to put your vertex at 1, 2. Question 9. Now we have an h value and an a value. The h value being plus 2 will actually move it left 2. Now, since a is more than 1, that is also going to make the graph narrower. Now, when you make a graph narrower, it doesn't shift it. Your vertex will be at negative 2, 0. And then the final one actually has all 4 possibilities. Well, the plus 1 is going to move it left 1. The plus 7 is going to move it up 7. The negative is going to flip and 0.5, because that is between 0 and 1, makes it wider. Now, as far as where your vertex is going to be, left 1, -1, up 7, +7. So that is some examples of how to do these, and you don't even have to necessarily draw your graph. And then just to kind of quickly sum up on the final page, how does the value of K affect the graph? K shifts a graph up or down. How does the value of H affect the graph? Well, H shifts a graph right or left. And then how do the sign and absolute value of A affect the graph? A makes a graph narrower or wider, and if A is negative, the graph flips over the x-axis. So there is one final assignment on Schoology for 6.5. One of the things that it does say, since we are not actually in school, you do not need to worry about submitting graphs. It's just going to talk about what's the vertex, is it a maximum or a minimum, what are domains and ranges, but again, you do not actually have to turn in any graphs. So again, that's available on Schoology.